Dear civil engineers, welcome back to School of Civil Engineering. So in this lecture, I'm just going to show that how we can design a extra foundation by using our CSI SAFE 2020. So you know that already CSI have launched a new version of CSI SAFE. It's CSI SAFE 2020. So in our previous lecture, I have shown you that how we'll design a single footing. So here our data. So in this lecture, I'm just going to show that how we'll design our extra footing. So for that, I'll click here to take a new model. So from here I'll take a new model, and from here I'll take that option, and I'll use a display unit, then unit estate. Okay, it's okay. Just I'll take its concrete design code here, 31890. Then I'll click OK, and from here I'll take just grid only option, because I just need that option. Otherwise there are many options actually, but I'll not use that option now. I'll just go for that grid only option. So from here, okay, I'll take our spacing for our one footing to another footing. Okay, so here I'll take number of grid in X direction, I'll take 2, and number of grid in Y direction, I'll take 1. And from here, spacing of grid in X direction. So what will be the spacing of grid in X direction? I will consider my two columns distance are 8 feet. Okay, and grid in Y direction, no need to change that because we have only taken one grid in X direction. That's why this value will not be considered. So I'll just go here, okay, and no need to take any consideration here. So I'll just click OK. Now you can see here now only 2 points have created. So I'll just go here, plan view. Okay, so from plan view we have 2 points, only 2 points we have here. So you can see that here 8 feet, we have 2 points of 8 feet here on and here on. And also if you just go to if you can go elevation view to see that. So here that is in elevation view, and I'll go in plan view. So it's done. Now I'll create our here our 1 point, and here our another point, 2 points there, here 1 and here 1. So when it's done, now I'll go for defining materials. So I'll just go here, define materials property. So in a previous lecture I have just shown you that how we'll define materials property. So in this lecture I'll just use that concrete as a 4000 psi and a reinforcement as a 60 grade, here grade 60. So I'll use that too. And if you need to learn about that topics, that how we can change that or how we can add new materials, then I'll request you to watch our previous lecture. So that playlist are given in the description. So I'll just click OK. After that I'll click define, then section properties. What we need only slab section, and also we need a frame section. So first of all I'll go here for frame section, and I'll delete multiple properties. First of all I'll delete all of our properties because this is unnecessary for us, and I'll just click OK, and I'll just go here, add new properties, and from here I'll take a rectangular beam. So here I will take a section here. So I'll give here BEM, beam. Okay, I'll take a beam here, and this is a beam section, and also I'll just take our beam width. I'll consider as a 12 inch, and I'll consider our beam depth as a our beam depth I'll consider the same depth of our foundation. So if I consider our foundation will be 18 inch, so I'll take 18 inch with depth. Then I'll go design property data, and from here everything is okay. So flange dimension analysis property data, and here the longitudinal river and the confinement member river, and here I'll go for that. So cover to top, okay, to centroid. So actually this is the value of our cover from up surface from the upper surface of concrete to the longitudinal reinforcement centroid. So here I'll consider 2.5, and here for I'll consider 2.5. Oh no, I'll not consider 2.5, I'll consider 3.5 because we consider almost 2.5 inch clear cover, directly clear cover for the beams or any materials which are contact with our soil, so okay, or earth. So here that's why I have just taken 2.5 and 1 inch for our reinforcement. So here 2.5. okay, so it's done, and total 3.5. I'll just click OK. I'll just click OK, and now I can delete that one. Done. Then okay, after that I'll just again go here, section properties, then slab section. From slab section I'll just delete that one, and they have a slab section, slab 1. Just I can modify that one. I'll just go for modify. I'll select and I'll just give it as a footing, f-o-o-t-i-n-g, footing. So from here I'll select footing, and from here materials property, you have to select material property and modeling type, which types of modeling you're going to do. I will use shell thin. You can use shell thick and membrane as per your requirement. So after that, here what will be the thickness? I have considered 18-inch thickness first of all. So I'll just click OK, and it's done. Then I will go here. Okay, sorry, I need to define another one. I'll just come here, add new properties. I'll just give here column stiff, COLSTI, column stiff, and the materials properties are okay here. And from here I'll select stiff, and what will be the thickness? I will consider here the thickness is here, or thickness is same as our footing. Okay, I mean footing thickness, our column stiff will be same as our footing thickness. Then I'll click OK, then I'll go for OK. So it's done. Now when it's done, after that I'll just go for our next step, and here define. After that header river size, so I'll not use the bar number, I will use bar diameter situation. So I'll clear wall, then add, and from here SI, I'll click OK. So here the number of bar 10, 8 mm, 10 mm, 12 mm, 14, 16, 18, 20 mm bar that are required for my design. So it's done. After that again I'll just go here, define. So this is section properties equal, and we'll go for spring properties. So we'll use area spring. I'll just click here for area spring, and from here add new properties. I'll just give its name as BC, bearing capacity, and now we need the subgrade modulus. Okay, compression only. For compression I'll select that for compression only, and I need soil subgrade modulus. So I will use that soil subgrade modulus. Actually, what is that soil subgrade modulus? The soil subgrade modulus is nothing but our bearing capacity of our, I mean ultimate bearing capacity of our soil divided by allowable settlement. So I'll use the Excel file to calculate that, and I'll provide that Excel file for free. So here our a simple Excel file I have generated. So here if we just click allowable bearing pressure, so first of all you have to provide allowable bearing pressure. So what is the allowable bearing pressure? Your unit can be different, but you have to put here the value in TSF. So what is the allowable bearing pressure? First of all you have to provide that value here. So my allowable bearing pressure are on, if I consider that our all allowable bearing pressure are 2. Okay, and what is the factor of safety? I'm just considering our factor of safety are 3, and allowable settlement in the foundation. So what is the allowable settlement? Actually as per your code or as per your soil test report or subsoil investigation report. So my allowable bearing pressure are at 2 TSF I have considered, and factor of safety 3 I have also considered, and allowable settlement in foundation, that is 2.5 as per my soil test report. So after that we can see here our value, we need that value in keep per inch square, that means keep per inch cube. So I'll just go here, and here keep per inch cube, and our value is 0.09 something. So I'll just copy that. I'll just right click and paste as value, and I will copy that value to our software. That's it. So that's it. So here our subgrade modulus for compression only, I'll just go for OK, and then OK, and again I'll go. So when everything is okay, I'll just go here for a load case. Okay, the only thing we need, that is load case. So here dead load and live load are already available for our, sorry, I'll go for here load pattern, not load case. So here our dead load and live load already assigned. So I'll design our foundation for only dead load and live load. Okay, I'll just okay, and then I'll go to combination, and from here you can define combination as per your requirement, but from here I will go for add default combination, and here for concrete and slab or beam, so I'll not use that combination. I'll just close, and from here I will add a combination combo 1, and for deadlocked 1 factor, and for live dot there is also 1, and here a combination. Okay, this is as per my code. I have just taken that combination of 100% of dead load and 100% of live load. And if you have different, or if you have another combination, if you consider earthquake load or another load, then you may face some another combination, or I mean you may have to create some another combination. I'll just click OK. For on combo, I'll just go for first time. Now when it's done, now we'll go for modeling or start. So before starting modeling, I'll just go draw. I need 4 point. So from here I'll consider draw a joint object. So from here, that is inch, so I will consider the foundation I want to create. I'll consider my foundation is 4 feet by 6 feet. Okay, 4 feet by 6 feet. So what I'll do actually, I'll just 4 feet by 4 feet. I'll consider our foundation is 4 feet by 4 feet. So in X direction, I'll just consider 24 inch, that means 2 feet, and in Y 24. And after that, I'll just click here. Okay, and if I just go here for plan view, just see here a point have created. Same way, I'll just go here, draw joint object, and from here in X I'll go 24, and the minus Y I'll go for 24. So minus Y, so here it will create a point -4, and I'll just create a point for minus X in that side, and also I'll create a point for plus Y 24. Then I'll just click here, and here again I'll create a point same for plus Y. Then I'll create a point for minus 24. Then I'll create a point for plus X 24. Then I'll create a point for minus Y 24. And if I just click on plan view, now see, you can see here we have created 4 points where we're going to apply our footings. Now from here or here, I'll take that option, and from here I'll just select footing, and simply just click here and draw your slab, and also click here and draw your slab here. So after creating that slab, just go to that option, quick draw a point around here, so you can use that option. Okay, but before that, I'll just go ahead, draw, then I'll go for draw joint object, and I'll take a point in 1 feet away from our center. From here I'll just go in X minus X for 12 inch, and I'll click enter, and here it's done. And in that side also I'll just go for positive 12 inch from that center. And if I just go again, if I click here, so just see here a point and here a point. With respect to that 2 point, we'll draw our column stiff. So I will use that option, draw a point around a draw a draw area around a point. So from here, what will be our from here I'll select our column stiff, obviously, and from here our dimension. So what will be our column dimension? I'll consider our column dimension will be 12 inch into 12 inch initially, 12 inch into 12 inch. And from here I'll just click here, so this is our column stiff, and I'll click here, so this is our another column stiff, right? So in this way we are able to create our foundation perfectly. So it's done, our column stiff, we have created our column stiff. Now we'll go for the next step. What is our next step? Now we'll apply load and soil subgrade properties. So I'll just select that foundation, and also I'll select that foundation, and I'll go for the another thing. I'll just go assign, and from here from analysis we'll just go for response. sorry, from shell, we will go for area spring. Just we'll click shell, and here just see we have the option area spring, and we'll select BC, and then I'll click apply. So we have provided our BC and bearing capacity or soil subgrade properties here. After that, we'll go for the next task. I'll just escape, and I'll select that point, and I'll select that point, and I'll randomly apply same load on both column. Okay, so to assign load, I'll just go assign, and I'll go for here. I'll just actually from that option. Okay, so we'll go for that option here, the force. I'll just go here, and from here we'll select dead load and live load. So I'll consider the dead load as itself weight, and the live load I'll consider, okay, I'll consider our dead load will be there have some option here. So what is the option here actually? First of all, here for global jet. Okay, so global jet I'll provide in downward direction, so global jet means upward direction. So what will be the value here? So I'll consider 25 keep of dead load for that foundation, or suppose 35. Okay, 35 keep of dead load. And if you have moment, you can apply here. So I'll not consider any moments here at this time. And the most important thing is the size of load for punching shear. So what will be the size of punching shear? Obviously it will be the size of your column stiff. So what is our size of column stiff? 12 inch into 12 inch. This is the most important thing. And 35. And if you want to apply the moment, you can also apply. I'll just click apply. So here the 35 again, select that point and select that point, and go for live load, and I'll assign live load for suppose 40. And if I apply some low moments here, so if I apply moment for 3, and for X if I moment 1, so and also our column size was same 12, the replace with the existing load, then apply, then okay. So here are the value, and if we just go in free view, just see here we're seeing our load here. And also if you go for extrude mode, okay, so you can see our data are okay. Now when everything is okay, go to plan view and go to analysis. I'll just click here, run analysis and design, and I'll save that data here. So stuff footing stuff f double. Okay, actually we have to provide some beam here, but we did not provide it here at this time. So after some time we'll go for it. I'll just click OK and wait for some time. Now see here we're seeing our okay, it's showing us some warning and on information. Actually take meshing at area 1. So here it's telling us for meshing. I'll just unlock again, and I'll right click and area. I'll just find out. So we do not provide any area mesh or anything, actually no need at this time. So and from geometry, it's okay, everything just we can ignore that our meshing issues. So I'll just go for analysis again. Now we can check that. Now we can check that our our displacement here. If we check our displacement here, that is uz equal to 0.26. This is very less. And here sorry, this is for dead load. And if we just go display, then show deform shape, okay, and if we go for combination combo 1, and if I just go apply, now we'll check. So what is the displacement? 0.53 in that side. So here 0.54, and in that side this is also very less, okay, less than 1. So what was our allowable settlement or deformation? That is 0.98, but it's okay. And after that, if I just click here, so everywhere the settlement value is okay. And if we go for the next tasked. So what is that? If we just if I just click here, display, okay, sorry, if we click here, also here display support value. So here no, actually we'll not see for our support value, we'll see for soil pressure, display soil pressure. I'll just go here for combo 1, okay, and everything is okay, and I'll just click over here. Now if I just click that side, so here our settlement is okay, allowable settlement is okay, but we're seeing that our what was our allowable settlement, sorry, allowable bearing pressure 448008, but here we're seeing that it's huge, it's huge. In that side this is very less, right, 27, okay. In that side it's under allowable value, but in that side it's not. So to reduce that issue, we'll go for extra foundation. Now I will add a column here, and also I'll check something. I'll just go display, okay, and show punching shear design. So actually our punching shear design is also okay, and it's very less, it's very less, 0.027, okay. So we are able to reduce our column thickness, or I mean our slab thickness. So we'll go for next. I'll just unlock, and after that I'll just use that option, draw beam or something. Then from here beam, okay, beam are also available, everything is okay. So the beam property we have assigned here, and from that point to that point I'll apply a beam. So we have applied a beam, and now again I'll go for analysis and see what happened. Okay, I'll just ignore that warning. Just okay, actually this is nothing actually. Actually this is the issue of my graphical, I mean this is the graphical issue, so I'll just ignore that. Just see here also they have some graphical issue. And if we just click here, so in that side, okay, our settlement is okay. Now I'll just go for display, and from here or from here see our soil pressure, so everything is okay. I'll just go for apply, and in that side it's also huge, but in that side now it's also huge, or the soil, I mean soil pressure is huge at that side, but in that side it's have reduced little bit, right? And we're seeing that our maximum is now 7476. So what we have to do, I'll just close. What we have to do, we have to increase our foundation size actually. Then I'll go for unlock, and from here I'll increase our foundation size little bit. Then I'll just to do that I'll go here draw, then draw joint object, and from here in y direction I will consider 6 inch in y direction, here and here, and in opposite y direction, that means minus 6 inch. So here and here. When it's done, just click here plan view, or click here view, then refresh Windows, your value will be here. Now click here that reshape object, select that on, and just move it here, and move it here, and click here, and also again move it here, again click and move it here perfectly. And also click here and select, move, click, select, move, click, and move here, and also move here. So it's done. Okay, now what will do, escape, and after that again I'll run it. We'll just ignore. Okay, now okay, I'll just ignore it again. So I'll just go for a soil pressure for combo 1, show fill, show values also. I'll just click here. So now see the magic, in that side it's also under allowable value, in that side also it's under allowable value. That means our value is okay, perfectly our value is okay. So I'll just go for close, and if I just go for that option, then axial force for combo 1, like just see here the value of our axial force, and if I just go for shear 2 and here the value of our shear 2 for our beam, and for shear 3 so here for shear 3 this is if I just show values, okay, so our shear are 0, and if we go for moment and for moment 3 for beam, it's record moment 3, just see here 62.78. so here the value for our beam, right? So actually also you can check that for your structure. Now I'll just actually in our previous lecture I've shown you that how we'll assign our in our next lecture I have shown you that how we'll assign our design strip from here, okay, but in this lecture I'm not going to show that. I'll directly go for our finite element based design. So I'll just go display, then show slab design. I'll just click here, and for our strip based they have no available option. I'll just go for finite element method, and I'll use impose minimum reinforcement, and I'll just move it here and I'll apply. Just see here it's showing us our minimum reinforcement. What will be our minimum reinforcement? Now I'll just go for that option, typical reinforcement bar set. So I'll use number 16 mm bar, and for top I'll use 12 mm bar, and for bottom 16 mm bar, and first of all I'll try for 12 inch into 12 inch spacing. Now if I apply, just see here also we got little bit. So oh sorry, we are for top here, so I'll consider only for top. So here for top we required if I just go for 10 inch spacing, just we need little bit reinforcement. So if I go for 8 inch with 12 inch bar, also we need some reinforcement here. So I'll just go for 16 mm bar for top, okay, then I'll click apply. Now here no need, just here we require little bit, so I'll just go for 7 inch. Also it's okay, but here we need little bit, so I have to go for 6 inch. Just see when I have provided for 6 inch, just we no need any reinforcement. So we have to provide for top direction 1, and for direction 2 I'll just again apply. So for direction 2 it's also okay, but I can check for direction 2 if I just go for 10 inch, okay, we need little bit. If we go for 8 inch, okay, for our direction 2, for our second direction, in that direction our reinforcement requirement is little bit less than our direction 1, okay, so our top is okay. Now if we just go for direction 1 for bottom, if I just apply here, and now 16 mm for 12 inch center to center is not okay, then I'll go for directly 8 inch. So it's in that side it's okay, and for that foundation it's okay, but here we need little bit, so I'll go for 7 inch, and also I need little bit. So if I go for 6 inch, for 6 inch it's also required a little bit here, and it's very less. If you want you can ignore that, but I'll not ignore. I'll go for 5 inch here and apply. Now see, we have done with that value, right? And now if we go for the second direction of bottom lever, if I apply, then it's okay. Now for second direction, if we go for 6 inch, then it's also okay. For 8 inch, just let me check, record little bit here. So if we just go for 7 inch, then also they got some. So in a second direction we're able to design our member with 6 inch 60 mm lever, center to center, 6 mm at the rate of 6 inch center to center, and for top for second direction top 8 inch 6 mm bar with 8 inch center to center. So this this is the way to design our extra foundation. So thank you very much, and if you think that that's helpful for you, please like our video, obviously share our video, and give us super like so that you can support us financially, and also join as a member in our channel to support us. So thank you very much.